Do you think you understand what UFOs are? The truth is surprising. When you see something unexplainable in the sky, your mind jumps straight to aliens. But Richard Feynman, one of the greatest physicists of the 20th century, had a completely different approach. And what he discovered will change the way you think about evidence and perception. Let me show you. My name is Richard Feynman. Not literally, of course, but I'll walk you through his reasoning. Feynman had a gift for tearing down extraordinary claims with brutal honesty. And when it comes to UFOs, he revealed something most people don't want to hear. What you see isn't always what you think you see. Imagine I come up to you and say I saw a dragon. A real dragon. Breathing fire. Flying over the city. Would you believe me? Probably not. You'd want evidence, photos, videos, maybe even dragon scales. Why? Because extraordinary claims require extraordinary evidence. That's not just a catchy phrase. It's the foundation of scientific thinking, and Feynman applied it religiously. Now compare that with UFOs. Thousands of people claim they've seen unidentified flying objects. Since 1947, when Kenneth Arnold reported flying discs, there's been an explosion of sightings. Lights in the sky, saucer-shaped objects, impossible maneuvers. And what's the conclusion most people jump to? Aliens visiting Earth. But hold on. Think about what that means. If they really are aliens, we're talking about beings who've mastered interstellar travel. Beings who've conquered distances measured in light years. Technology so advanced it breaks every law of physics we know. And what's our evidence? Eyewitness accounts, blurry photos, low-quality videos. Maybe radar picks up something weird once in a while. Feynman would look at that and say, the claim is huge. Aliens, interstellar travel, secret visits to Earth. But the evidence? Weak, shaky, easily explained by other causes. And here's the thing. Eyewitness testimony isn't reliable scientific evidence. Why? Because human perception is flawed. Incredibly flawed. Think of it like an experiment. Have 10 people watch the same event. A car crash, an object in the sky, a face in the crowd. Now ask them to describe what they saw. What do you get? 10 different stories. Not because they're lying, but because your brain isn't a camera. It doesn't record reality like a machine. It interprets. It fills gaps. It adds patterns. Research on eyewitness testimony shows that even in controlled settings, people mess up. They misidentify suspects. They report details that never happened. They're swayed by suggestion, emotion, and expectation. Now put that into the scenario of a UFO sighting. It's dark out, the object is far away, it's moving fast. The person is startled, maybe scared. You've got the perfect recipe for seeing things wrong. But here's where it gets really interesting. The whole idea of flying saucers didn't just happen on its own. It was invented. First, the context. 1947. Kenneth Arnold describes objects moving like a saucer skipping across water. Second, the media jumps in. They take his description as flying discs, headlines, illustrations. The image of a silver saucer zooming across the sky captures everyone's imagination. Third, everyone starts seeing them. Before Arnold, reports were fuzzy, strange lights, weird objects. After him, suddenly saucers everywhere. Why? Because your mind is suggestible. When you expect to see a saucer, you see one. Feynman got this. He knew that your mind hunts for patterns, hunts for meaning. And when faced with something you don't understand, you make up explanations. Aliens are exciting, satisfying in a way, but not the most likely explanation. So if they're not aliens, what are people actually seeing? Here's where it gets really interesting. Because the answer is right in front of you the whole time, literally. In the air above your head, the atmosphere, that layer of gases wrapping around our planet. It looks simple, transparent, harmless, but the atmosphere is pulling off magic tricks all the time, and most people have no clue what it can do to light. Start with the basics. Let me do a thought experiment with you. Light travels in a straight line, right? Wrong. Dead wrong. Not when it passes through materials with different densities. When light goes from air into water, it bends. That's refraction. You've seen it. Stick a spoon in a glass of water. What happens? It looks bent. Light changes direction when it passes from one material to another. Now apply that to the atmosphere. The atmosphere isn't uniform, it has layers. Temperature shifts, pockets of warm and cold air. Those variations create what scientists call density gradients. When light passes through them, it bends. And when it bends in weird ways, you get surprising optical effects. One of the most striking is temperature inversion. Normally, air gets colder as you go up. But sometimes the opposite happens. Warm air gets trapped over cold air. This creates an atmospheric lens. And that lens does weird things. It takes light from a distant object and shoots it into the sky. It makes things look like they're floating. It twists shapes. It creates duplicate images. This isn't theory. It happens. It's documented. Superior mirages. Fata Morgana. Real stuff caused by atmospheric refraction. Ships floating in the air, inverted islands, entire towns appearing out of nowhere. And if you don't know what you're watching, it looks impossible. Supernatural. Feynman had a story about this, and it shows exactly why rigorous investigation matters. First, the report. Witnesses said they saw a bright object hovering and moving erratically. Looked controlled, looked intelligent. Second, the investigation. Feynman, being Feynman, didn't buy the story right away. What did he do? He checked the atmospheric conditions, the time, the object's position relative to the horizon. Third, the answer. It was Venus. Plain old Venus, bent by the atmosphere. Temperature variations made Venus's light dance around, made it look like it was moving, made it look like it was flashing. Think about that for a second. The witnesses weren't making it up. They really did see something strange. But it wasn't a UFO. It was physics. But atmospheric effects are only half the puzzle. Here's the other crucial piece. Cognitive bias. Pattern recognition. Agency detection. These are wired into your brain because they kept your ancestors alive. Seeing a pattern in rustling leaves could mean a predator. Better safe than sorry. And agency detection, thinking something's being controlled, was also useful. If something moves weird, assume it's intentional until proven otherwise. The problem is, these mechanisms never switch off. So when you see lights jumping around in the sky, your brain says, this is being controlled. It has intention. It's intelligent. Even when it's just atmospheric refraction creating the illusion of movement. Think of the atmosphere like a funhouse mirror. Ever been in one? Mirrors that twist your image. Make you look tall, short, fat, skinny. You know it's you, but the image is warped. The atmosphere does that to light. It takes something ordinary, a planet, a star, even a jet flying far away, and warps it. And if you don't realize you're looking through a warped mirror, you think the warped image is real. And it's not just Venus. High-altitude jets, weather balloons, satellites, lenticular clouds that form disk shapes because of wind conditions. All of these look weird under specific atmospheric conditions. Mix in low visibility, relative motion, and what you expect to see, and you've got a UFO report. Eyewitness accounts are unreliable. Cognitive biases make it worse. And now you see the whole thing. The atmosphere warps the light. Your mind fills in blanks. And the alien story sounds exciting and satisfying. But it's not the simplest explanation. It's not the most likely. And this is where Feynman's approach gets powerful. Because what UFOs teach us is bigger than UFOs. It reveals how to think about extraordinary claims. Here's the core of Feynman's philosophy, and it applies to way more than just UFOs. Feynman wasn't skeptical because his mind was closed. He was skeptical because he was honest. He knew that believing something without good evidence isn't a strength. It's gullibility. And gullibility gets you nowhere. It makes you vulnerable to mistakes, to deceptions, to believing comfortable lies instead of hard truths. The principle is simple. Your belief should match your evidence. Weak evidence means weak belief. Strong evidence means strong belief. That's not cynicism. That's intellectual honesty. Think of it like a muscle. Intellectual integrity is a muscle. Like any muscle, you need to work it. How? 3 things. First, say, I don't know when you don't. No excuses. No dressed up speculation. Just, I don't know. Second, resist filling in the blanks. Your brain wants to solve it, wants to explain it. Don't let it. Leave the gap open until you have real data. Third, demand evidence for extraordinary claims. The bigger the claim, the bigger the evidence needs to be. And here's what most people get wrong. Saying "I don't know" isn't weakness. It's strength. It's honesty. It's knowing your limits and being willing to dig deeper instead of grabbing the easy answer. Now let's get to something current. The Pentagon has released reports about unidentified aerial phenomena, UAPs. They acknowledge there are objects nobody's identified. Military pilots have seen things they can't explain. Radars picked up movements that don't match known aircraft. But what does that actually mean? Here's the key. Unidentified doesn't mean alien. It means exactly what it says. Unidentified. What could it be? Foreign tech, atmospheric stuff, sensor glitches, electromagnetic interference, tons of things that have nothing to do with aliens. The question isn't what we want it to be. It's what the evidence actually shows. The burden of proof matters here. In science, whoever makes the claim has to prove it. If you say it's an alien, you've got to back it up. And proving doesn't mean saying you saw something weird. It means actual data, physical stuff, something you can test and replicate. Here's another thing. Scientific instruments beat human eyes. Why? No bias, no interpretation, no filling blanks. A good camera captures what's there. A spectrometer measures exact wavelengths. A radar tracks movement accurately. These tools don't get fooled by atmospheric refraction or what you expect to see. If real evidence of aliens existed, instruments would catch it. Over and over. Repeatedly and verifiably. What do we actually have? Conflicting reports, vague evidence, lots of speculation. Feynman had a famous line about scientific integrity. He said the first principle is, don't fool yourself. And you're the easiest person to fool. That hits deep, because it recognizes your greatest enemy in finding truth isn't someone else. It's you, your desires, your expectations, your biases. So how do you apply that? How do you stop fooling yourself? Feynman followed 3 basic rules. First, be rigorous. Question your own assumptions, not someone else's, yours. Second, look for other explanations, always. Before buying something crazy, rule out the obvious. Third, be honest about what you know and what you don't. That honesty isn't weakness, it's where good thinking starts. And that brings us back to UAPs. Some of those modern, unidentified aerial phenomena stay unexplained. And you know what? That's okay. Unexplained isn't a problem. It's an opening. A chance to investigate. To collect more data. To do real science. But jumping to aliens without investigation? That's not science. That's fantasy. Look, there's nothing wrong with imagining. With wondering if we're alone in the universe. That's a great question. But there's a gap between asking and claiming. Between curiosity and being sure. And Feynman defended that gap. Curiosity and skepticism aren't enemies. They're partners. Curiosity makes you ask. Skepticism keeps you real about the answers. Together they build science. And you can use this everywhere. Because that pair of curiosity and skepticism works everywhere, not just in labs. Think about how many crazy claims you see. On social media, in news, in conversations. Someone says something wild. Sounds too good to be true. Or too bad. Or just weird. What's your gut reaction? Accept it? Share it? Or pause and ask, what's the evidence? That pause. That question. That's Feynman thinking in action. And the more you do it, the easier it gets. You build an internal filter. A BS detector. And that doesn't make you cynical. It makes you sharp, thoughtful, harder to fool. And when you apply that Feynman approach to UFOs, it all clicks. The truth about the atmosphere is that most sightings have normal explanations. Refraction, mirages, planets, airplanes, balloons, clouds, natural stuff that looks weird under certain conditions. Not boring. Elegant. Physics doing its job. Making beauty. Making mystery. Just explainable mystery. And for those few cases that stay unexplained, that's the beauty of Feynman's method. He'd say, great, we don't know. Let's investigate. Get more data. Use the scientific method. And if we find something amazing, we'll have proof. But until then, the simplest explanation is probably right. And the simplest doesn't involve aliens from another planet crossing space to flash lights and disappear. Think about the numbers. Do the math. First, distance. The nearest star is over 4 light-years away. That's 24 trillion miles. Second, what it takes. Getting there needs insane energy. Tons of time. Unless they can break the speed of light, which is pure speculation. Third, what they do. After all that effort, then what? Show up, do some weird moves, leave? No contact, no talking, no proof they were ever here? Does that make sense? Compare that to light from Venus bent by the atmosphere. Which needs fewer assumptions? Which fits what we know about physics? Easy answer, and that's why Feynman didn't buy UFO reports. Not because aliens can't exist, but because the evidence for that claim was weak next to much simpler answers. Remember the dragon example? We circle back to it. If I say I saw a dragon, you'd want proof. Not because dragons can't exist in theory, but the claim goes against everything we know about biology and physics. My word alone won't cut it. You'd need to see it, study it, confirm it's real. Not a trick, not special effects, not a hallucination. Same rule for aliens. The claim is huge, so the evidence needs to be huge. And eyewitness stories, when simpler atmospheric explanations exist, don't measure up. So what do you do when you hit something you don't understand? Here's Feynman's answer. First, admit you don't understand. Don't make stuff up. Don't go wild guessing. Just say, I don't know. That's honest. Second, investigate. Get data. Look for other explanations. Test ideas. Do the work. Third, match your belief to the evidence. Weak evidence means weak belief. Strong evidence means strong belief. Simple. And here's the thing. This isn't just about UFOs. It's how you deal with any claim, any story, any narrative. It's building a critical thinking habit that shields you from being fooled and points you toward truth. And the real truth about UFOs? The truth about our atmosphere. Our sky is packed with real wonders. Optical effects that break expectations. Light tricks that make amazing illusions. Mix that with your mind hunting for patterns, and you get alien stories. The stories are cool, but reality's more elegant. It's physics. It's the atmosphere. It's light doing what it should. Feynman's message is simple. Intellectual honesty isn't a drag, it's freedom. Saying you don't know is courage. Evidence matters. Stories can lie. Scientific thinking doesn't kill wonder. It frees you to awe over what's truly amazing. The universe's complexity, how elegant natural laws are. The beauty of truth earned through hard work. And now you have the tools. What do you do with them? Next time you spot something weird in the sky, pause. Use Feynman's method. Ask, what explains this? Atmosphere? Natural stuff? Something normal that looks odd? Eliminate the obvious first. Only then look at the wild stuff. And even then, match your belief to what you actually know. This works for anything you hear. Social media, news, talk. Get in the habit of asking, what's the evidence? Does it support this? Is the conclusion proportional to what you know? If no, you have two good options. First, say I don't know. No shame. It's honest. Second, dig deeper. Get data. Test ideas. Keep your curiosity alive and skepticism sharp. That's how you grow. How you really learn. How you get closer to truth, even when it hurts. That's how Feynman lived. You can too.